Okay, hello, welcome to the session on solving some problems, question on basic applied mathematics. And today we are going to solve question on trigonometry and question on matrices. Question on trigonometry always comes question number 8 in basic applied final exam, and question on matrices is question number 9. So the first part of our question for today, which is all about trigonometry, is if you are given sine of an angle A, this is equal to 4/5, and again you are given cos B equals to 12/13. We are asked to find the value of cos A plus B. This is equal to how much? We are asked to find the cos A plus B equals to how much? So solution for this is simple. We need cos of A plus B. This is just the compound angle. We can just expand this as cos A, cos B, then minus sine A, sine B. Of course, in our question, we have sine A, which is that one. We have cos B, which is that one. We need what is cos A and what is sine B. So we are given sine of an angle A equals to 4/. To find the value of this means that if we need the cos of an angle A using trig identity, cos squared A plus sine squared A, this is equal to 1, and then cos squared A will be equals to just 1 minus sine squared A. And this is nothing but if we just take square root, we get cos of A equals to 1 minus sine squared A square root. And this is equal to 1 minus sine of an angle A is given as 4/5, so you just take 4/5 but square under square root. So this will be equals to 1 minus 4 squared is 16 divided by 5 squared is 25 and right. 1 is just because the denominator is 25, I can just put 25/25, which is 1 minus 16/25. Then taking the square root, and this means this is equal to 25, take away 16 is 9 divided by 25 under square root. And then finally we'll have this square root of 9 is 3 and the square root of 25 is 5. And this means that cos of an angle A, so therefore cos of an angle A equals to 3/5. So for the substitution, of course, we have now its value. We need sine. Again, we are given cos beta. Again, cos B equals to 13. 12/13, sorry, 12/13. We need sine B. So from sine squared B plus cos squared B equals to 1. This is a well-known trig identity, the basic trig identity. So we have sine squared B will be equals to 1 minus cos squared B. And now this will be taking square root. If you take square root both sides, we'll get that sine B, square root of sine squared is just sine B. This is equal to 1 minus cos squared B under square root. So this will be equals to 1 minus, what is cos square B? Cos B is 12/13, so it is 12/13, but square, then taking square root. This will be equals to 1 minus 12 squared is 144, divided by 13 squared is 169, then take square root. This will be equals to, this is 1, and the denominator is 169, so I can just put 169 divided by 169, which is 1. Minus 144/169, then take the square root. I just make the denominator being the same, then I just subtract. So it will be equal to 169 minus 144. Taking square root divided by equals to 1 minus what is cos square common denominator. Cos B is 12/13 square root of 25 is 5, and square root of 169 is 13. So here we now have sine B. So sine B is now equals to 5 over 13. That means we have sine B, we have cos A, we have sine A, and we have cos B. So we can just find the cosine of A plus B. So therefore, cosine of A plus B will be equals to, as I said, is the expression cos A times cos B minus sine A times sine B. And this is equal to cos A. Our cos A is 3 over 5, so we put 3 over 5 times cos B. Cos B is given as 12 over 13. Then minus sine A. Sine A is 4 over 5, so you put 4 over 5 times sine B. Our sine B is 5 over 13. 5 over 13. Then we can just simplify if we can. 3 times 12 is 36, divided by 5 times 13 is 65, minus 20 divided by 65. So just take 16 minus 20 is, 36 minus 20 is 16, divided by 60 is now equals to 5 over. Can check it and simplify. That means we have sine B, we have cos A, 11 we have sine A, which has factor 1 in itself, so we can just find the cosine of A. So there sine A, sine A is 4 over 5, so A plus B, cos B is given as 6 plus B. So therefore, so here we now have 1 minus what is cos. The answer will be equal to, so what we have used here is just the compound angle formula for cos, the denominator being the same, cos A plus B, which is this one, and we have used the basic trig identity, which is cos squared of an angle plus sine squared of an angle equals to 1, to get each of the missing values. Okay. The second part of this question is we are given sine x as A. The second part is, if A is sine x and B is cos x, then simplify the following expression. We are given that this is part B. We are given that A equals to sine x and B equals to cos x. We are asked to simplify the expression with 1 minus B squared square root times A plus B times square root of 1 minus A squared. So we are given the value of A as sine x and value of B as cos x, then we are asked to simplify this expression. What we need here is just to make the direct substitution of the given value in the expression and simplify our expression using the trig identities. So 1 minus B squared square root times A plus B times square root of 1 minus A squared. This now becomes 1 minus B. B is cos x. So we just take the square of B, which is cos squared of x square root, times A. Our A is sine x. Just put sine x. Plus B. B is cos x. Then times the square root of 1 minus A. A is sine squared x. And then at the end we'll have 1 minus cos squared x is just sine squared x. So sine squared x square root times sine x plus cos x times 1 minus sine squared is cos squared x. That is sine squared x plus cos squared x equals to 1. This is the basic trig identity that you have used here. And if you need cos squared x, this will be equals to 1 minus sine squared x. That's why we have this expression here. 1 minus cos squared x is sine squared x, and 1 minus sine squared x is cos squared x. Again, this will be equals to square root of sine squared x is just sine x times sine x plus cos x times square root of cos squared x is cos x. So finally sin x times sin x is sin squared x plus cos squared x, and this is equal to 1 because the basic trig identity sine squared of an angle plus cos squared of an angle equals to 1. So sine squared of x plus cos squared x equals to 1. So therefore, the expression square root of 1 minus a squared times b plus b times square root of 1 minus a squared, this is equal to 1. That is equals to 1. So what we did here is just direct substitution of the given value in the given expression and simplify using the trig identities. And the trig identity that we have used here is just the basic one. Sine squared x plus cos squared x equals to 1. And of course, sine squared of any angle plus cos squared of that angle is equal to 1. So that is the second part of our question. See, let's continue with the third part. The third part is solve the following equation. See, solve the following equation. The question is solve the trigonometric equation for cos theta minus 3 sec theta equals to 2 tan theta. But for the value of theta, between negative 180 less or equal to theta less or equal to 180, that the value of theta should lie within this range. So we are asked to solve for theta in this case. This is a trigonometric equation. It's equation because it has equal sign connecting two sides, that's left hand side and right hand side, and it is called trigonometric equation but because it involves the trig functions. So we have 4 cos theta minus 3 sine, it is sec theta equals to 2 tan theta. What we need to do here, because we have 3 basic trig functions, we have cosine, we have tangent, and we have sine of an angle. So we need to change all of the trig identities, trig function into only one function. We can decide to change all of them into cos, or all of them into tan, or all of them into sine. Now this is now equals to 4 cos theta minus 3 sec theta is just the reciprocal of cosine of an angle theta equals to 2 times sine, tan theta is just sine of an angle theta divided by cosine of an angle theta. So we can see now the denominator is 1, here is cos theta, here is cos theta. So I just multiply by the LCM of the denominator, which is cosine of an angle theta. Multiply each term by cosine of an angle theta. We'll get 4 times cos squared theta minus 3. That is cos theta times 3 over cos theta. Cos theta and cos theta goes. And this is equal to 2 sine of an angle theta. Because if you multiply sine theta over theta times cos theta and cos theta goes, we remain with that simple expression. Then, but cos squared theta, this is nothing but it's 1 minus sine squared theta. You can just make this substitution. So this is 4 into 1 minus sine squared theta minus 3 equals to 2 sine of an angle theta. Then opening the bracket, we'll have 4 minus 4 sine squared theta. We just open the bracket and multiply 4 by each term inside the bracket. Minus 3 equals to 2 sine of an angle theta. And this is nothing but 4 minus 3 is 1. So it will be 1 minus 4 sine squared theta equals to 2 sine of an angle theta. Now we can make a quadratic equation here in terms of sine. So we'll have 4 sine squared theta plus 2 sine of an angle theta minus 1. This is equal to 0. We just take all of this part on the right hand side. Now we can see this is now quadratic in terms of sign. If you want, we can just replace sign by other variables, so we can just let sine of an angle theta to be, say, x. So we'll get, if sine of an angle theta is x, now we get 4 times x squared, which is sine squared, plus 2 times sine of an angle theta, which is now x, minus 1 equals to 0. This is now the normal quadratic equation, which we can use a scientific calculator to solve it, or we can use the known method of solving quadratic equation, either by splitting the middle term, or by using the general formula, or by using completing the square method. But in our case, we don't bother those methods. We can just use a scientific calculator to get the answer. Because the intention here is not to solve a quadratic equation, but it is to solve the trigonometric equation. So from here, using, say we can use the general formula. Because I don't have a calculator here, I can just use the general formula. The general formula, that is x is equal to negative b. B here is 2, so negative 2 plus or minus b squared, which is 4, minus 4 times a is 4, times b. B is, c is negative 1, that is 4ac, divided by 2a, a is 4. And this is now equals to negative 2 plus or minus square root of, this is 4 plus 16 divided by 8. And this is nothing but it is just negative 2 plus or minus square root of 20 divided by 8. So we can simplify this as negative 2 plus or minus 2 square root of 5 divided by 8. And then we can further simplify that expression by just dividing by 2 each term to get the most simplified expression, which is x now equals to just negative 2 plus or minus 1 square root 2 square root of 5 divided by 8, which is equal to negative 1 plus or minus square root of 5 divided by 4. That is the value of x. So if you need but we know x was equal to sine of an angle theta. So if we need theta now, it will be equals to sine inverse of x, and in this case it will be sine inverse of negative 1 plus or minus square root of 5 over 4. And this is nothing but it is so we have either now, so either x theta will be equals to sine inverse of negative 1 plus square root of 5 divided by 4, or sine inverse of negative 1 minus square root of 5 over 4. So you get 2 different values here. After getting the values here, the 2 different values here, we need to check if the values lies in between the given interval. So in our case, we can just check the correct answers here. In my case, of course, I had wow. So the answers are, we can just plug this into our scientific calculator and get the required answer. So finally, we must check if the given the obtained values lies in the given intervals. If the obtained values lies in a given range for theta. All the values or all the solution which lies out of the given range will be omitted in our case. So we need to check the values which lies in a given range. The range here is negative 180 up to 180 degrees. So if any value or any solution obtained out of this range will be omitted. That is the question about trigonometry. Now let's see the second question, which is all about matrices. It's a very important question, a very simple question, but it is a bit involving. One needs to be very careful when solving this kind of problems, because there is just a minor multiplication that we need to be extra careful. So the question is, the second question, part A, which is all about matrices. We are given two matrices, A, which is the matrix with entries 2, 2, 3, 4, 3, and 1, 1, 4. This is matrix A, and we are given matrix B, which is the matrix 2, 1, 2, 1, 5, 4, and 3, 0, 2. These are two matrices which are given. We are asked to find 3 times A minus 2 times B. This is called a scalar multiplication of a matrix. That is, the matrix is multiplied by a scalar. And in our case here, scalar is 3 and 2. It's just a scalar multiplication of a matrices. We have this is a 3 by 3 matrix, and this is also 3 by 3 matrix. Remember, adding or subtracting matrices is possible only when we have the matrices of the same order. If we have matrices of different order, then it will not be possible to add them or to subtract them. This is because when we are adding the matrices, we normally add the corresponding parts. We add the first entry of the first matrix and the first entry of the second matrix together, second entry and the second entry, third entry and third entry, and so on. So that's why adding or subtracting matrices, we need to have a matrices with the same order or same size. That is, n by n matrix can be added. So if you have the first matrix, maybe it's 2 by 1, and the second matrix is 3 by 3, we cannot add them together in that case. So solution here is simple. We need to find 3 times A minus 2 times B. This is equal to how much? It's just 3 times the matrix A is 2, 2, 2, 3, 4, 3, 1, 1, 4. Then minus 2 times matrix B, which is 2, 1, 2, 1, 5, 4, 3, 0, 2. This is matrix B. So what we do here first, before subtracting, we need to multiply each of the entry in the matrix by a scalar. Then it's called a scalar multiple of a matrix. So we multiply this number by each entry inside. And this is equal to 3 times 2 is 6, 3 times 3 is 9, 3 times 1 is 3, 3 times 2 is 6, 3 times 4 is 12, 3 times 1 is 3, 3 times 2, 6, 3 times 3, 9, 3 times 4, 12. This is called a scalar multiple of a matrix. We do the same for the second matrix, which is each entry is multiplied by 2 here. So we get the matrix of the nature. 2 times 2 is 4, 2 times 1 is 2, 2 times 3 is 6, 2 times 1 is 2, 2 times 5, 10, 2 times 0, 0, 2 times 2, 4, 2 times 4, 8, 2 and 2 gives us 4. So again, I have said that subtracting the matrix is simple. We just subtract the corresponding entries, which means the first entry of the first matrix, in the first matrix, we subtract the first entry of the second matrix. We just subtract the corresponding matrix. Just you can just write the note to subtract matrix here. Subtract the corresponding element, corresponding entries. These members of a matrix are normally called entries. So what we do, we just subtract the corresponding entries, which means if we take the last entry of the first matrix and the last entry of the second matrix and so on. So doing so, we'll get our answer as subtracting the corresponding entries, will get the matrix of this nature. That is 6 minus 4, we get 2. 9 minus 2 is 7. 3 minus 6 is negative 3. We are done with the first row. So 6 minus 2 is 4. 12 minus 10 is 2. And 3 minus 0 is 3. The last row, 6 minus 4 is 2, and then 9 minus 8 is 1, 12 minus 4 is 8. So this is the matrix that we need. That is 3A minus 2B. This is equal to the matrix 2, 4, 2, 7, 2, 1, negative 3, 3, 8. So this is the answer, which is this one. So what we did here is just, first we just take, find the scalar multiple of a matrix and then subtracting the corresponding entries. Okay. The second part of this question is, we are given the matrix, which is 3 by 3 matrix, B. The question is find the inverse of 3 by 3 matrix, which is given as 1, 2, 3, 2, 1, 1, 3, 1, negative 2. We need to find the inverse of this matrix. So to find the inverse of 3 by 3 matrix, we need to find some couples of things. But I like it to find the inverse of 2 by 2 matrix, which is simple. Here we need first to find inverse. Here first we find what you call the determinant. So we need to find first determine the determinant of a given matrix. In my case, I can just call this matrix, I can just give it a name, maybe matrix M. So we first determine the determinant of a matrix M. And determinant is just the length of a matrix. So we need to determine the length of this matrix. So determinant of matrix M, which is denoted inside a vertical bracket like this, is just nothing but it is 1 times the determinant. We just what we do, we just call the deletion of row. We delete the first row and first column and find the determinant of the remaining element. Here is 1, 1, 1, 1, 1, 1, negative 2, then minus 2. Then we delete the second column and the first row because we are doing expansion along the first row. So deleting this row and deleting this one, we remain with 2, 3, 1, negative 2. And lastly, we have 3 times deleting the last column and the first row, we have 2, 3, 1, 1. To find the determinant of 2 by 2 matrix is simple. So this will be equals to 1 times, we just take the product of the leading diagonal minus the product of the main diagonal. So this is 1 times negative 2. It's negative 2 minus 1 times 1 is 1, minus 2. 2 times negative 2 is negative 4, minus 3. 3 times 1 is 3, plus 3 times 2 times 1 is 2, minus 3 times 1 is 3. So here we have now 1 times negative 2 minus 1 is negative 3, minus 2, negative 3 times minus negative 4 minus negative 3 is negative 7, plus 3 times 1 minus 2 minus 3 is negative 1. So here multiplying, we'll get -3 plus 14 minus 3. So this is just the same as -3 plus 14 is 11. 11 minus 3 is 8. So it means the determinant of matrix M is, so therefore we have now the determinant of matrix M equals to 8. That is the first procedure, or first thing that we need to find in order to get the inverse of this matrix. Now the second thing that we need to do, finding the inverse of a matrix, especially 3 by 3 matrix, is to find what we call the minors of the matrix M. And these minors are just the determinants obtained by deleting rows and column. So the second thing, find the minors. These are the determinants obtained by deleting the rows and columns. So what we do here, we just take our matrix M, which is equal to 1, 2, 3, 2, 1, 1, 3, 1, negative 2. So we start by finding the minor, the first minor, which is M11. This is obtained by deleting the first row and first column. That is first row and first column, and this is the determinant 1, 1, 1, negative 2, and this is equal to 1 times negative 2 is negative 2, minus 1 times 1 is 1, and this is equal to negative 3. Then we find 1, 2, that is we delete first row and second column, first row, second column, so we have this is equal to 2, 3, 1, negative 2, so we'll have 2 times negative 4 is negative 2 is negative 4, minus 3 times 1 is 3, and lastly we get 7, and then we get 1, 3. We just delete the first row and third column, first row, third column. We have remained with these entries, so we'll have 2, 3, 1, 1. This is equal to 2 times 1 is 2, minus 3 times 1 is 3, and the answer is negative 1. Then we are done with the first row. We have deleted the first column, second column, and third column. We now shift to the second row. So we get now M21, which means we delete the first, the second column and first row. Second column, first row. We remain with 2, 1, 3, negative 2. This is equal to, that is second row, first column. So we have 2, 1, 3, negative 2. 2 times negative 2 is negative 4 minus 3, and this is equal to negative 7. And then we need to find M22, that is the determinant obtained by deleting first, second row and second column. Second row, second column. We have now, we remain with 1, 3, second row, second column. 1, 3, 3, negative 2. 3, negative 2. So the determinant here is simple. It's just 1 times negative 2, which is negative 2, minus 3 times 3, which is 9. And the answer is 11. Then we find M23. That is the determinant obtained by deleting the second row and third column. Second row, third column. We'll have 1, 3, 2, 1. And this is equal to 1 minus 6, which is equal to negative 5. Now we are done with the second row. We'll shift to the third row, which is the last one. So we find M31, which is equal to, M31 is just the determinant which is obtained by deleting the third row and first column. Third row, first column, we are remaining with 2, 1, 3, 1. This is equal to 2 minus 3, which is equal to negative 1. Then M32, this is equal to third row, second column. Third row, second column, we'll have 1, 2, 3, 1. 1, 2, 3, 1. This is equal to 1 minus 6, which is equal to negative 5. And lastly, M33, this is equal to, we delete third row and third column. we are remaining with 1, 2, 2, 1. This is equal to 1 minus 4, which is equal to negative 3. So lastly, we determine, that is third procedure to get the inverse, determine the what you call the cofactors, determine cofactors of matrix M. Cofactors is nothing but it's just Cij, I represent the row and j represent the column, is equal to negative 1 raised to 1 plus this is just I plus j of Mij. Mij is just the minus that we have obtained here, and this negative 1 I plus j determines the sign, whether it's positive or negative. So here we need to know what is C11, where I is 1 and j is 1. 1 plus 1 is 2. Negative 1 exponent 2 is positive. So which means M11 will not change the sign. So this will be equals to negative 3. Again, C12, this is 1 plus 2 is 3, which is odd. Odd number changes the sign. So this will be positive 7. And C13, this is equal to 3 plus 1 is 4, is even. Even does not change. So this is negative 1. And then C21, we get C21 from M21. And our M21 is this one. If we add them, we get 3 is odd. So it changes the sign. Here it will be 7. C22 will be equals to the same sign, because if we take 2 plus 2 is 4, negative 1 exponent 4 is positive, positive 1 times M22 remain the same, and lastly C23 will be equals to C23 we get from this one, and 2 plus 3 is 5, 5 is odd, we get negative here, negative times negative is positive, so we get 5. And lastly, C31, 3 times 1 is positive, so does not change the sign, negative 1. C32 will be equals to 3 plus 2 is 5, 5 is negative, so negative times negative become positive. And lastly, C33 will be equals to negative 3, because 3 plus 3 is 6, 6 is even, even does not change the sign here. So we have obtained the cofactors. After determining the cofactors, we need to determine what you call the cofactor matrix. You can just note here the determinant of M equals to 8, because we need to use them after some cases. So after that, then we need to form what you call the cofactor matrix. The cofactor matrix. So the cofactor matrix then, the cofactor matrix is then given by cofactor matrix I can just call C. This is just the matrix formed when the rows are just the cofactors. So it is just C11, C12, C13, C21, C22, C23, C31, C32, and C33. This is cofactor matrix. We can just take the values from what we have obtained. So this is equal to, should be equals to C11 is negative 3, so you can just put negative 3. C12 is 7, C13 is negative 1, C21 is 7, so 7, negative 11, C22, C23 is 5. Coming to the last part, we have negative 1, 5, and negative 3, negative 1, 5, and negative 3. So this is the called cofactor matrix. After getting cofactor matrix, the fourth step is to determine the adjoint of M. So adjoint of M is nothing but it is just cofactor transpose. We just transpose the cofactor and get the adjoint. Transposing the matrix is just changing the rows and columns. So we have the matrix with -3, 7, -1, 7, -11, 5, -1, 5, -3. We have changed, instead of having this column, these columns now become first row, this column becomes second row, and this one becomes the third row. Now the inverse of a matrix is just M inverse now equals to, after those steps, the inverse now is just 1 over determinant of M times the adjoint of M. And adjoint of M is just the matrix which is obtained by transposing the cofactors of matrix M. And this is equal to 1 over 8 times the adjoint of M is this one. So you have -3, 7, -1, 7, -11, 5, 1, -5, -3. Now multiplying this, just the scalar multiple. Multiplying here, we get -3 over 8, 7 over 8, -1 over 8. 1 over 8 times 7, we get 7 over 8. 1 over 8 times 11, we get -11 over 8. Then finally 5 over 8, -1 over 8, 5 over 8, and lastly -3 over 8. This is the inverse of the required matrix. So to get inverse of a 3 by 3 matrix, we need to do a couple of steps. The first step, we need to find the determinant of a given matrix. And what we did is just the row expansion. We have expanded the matrix along the first row. And then we need to find the minors of the matrix which are the determinant which are obtained by just cancelling the rows and column. Then after getting the minors, we find what called the cofactors. Cofactors is just obtained from the minors, but with this relation. If I plus j is even, then the sign does not change. If I plus j is odd, then we know -1 power odd number is negative, so the sign changes. After finding the cofactors, then form what we call the cofactor matrix. Then fourth step is to determine the adjoint of M, and the adjoint of M is just the transpose of the cofactor matrix. After then, the inverse is given by just taking 1 over determinant times the adjoint of M. And of course, that is what we had at last. So to finish up, let's see the last part of this question, which is Roman 2 of part B. Use the inverse obtained in 1a, which is this inverse, to find or to solve the values of x and y in the following system of equation. We need to use that inverse, that is M inverse we have obtained as -3 over 8, 7 over 8, -1 over 5 over 8, 7 over 8, -11 over 8, 5 over 8, and lastly, last column is -1 over 8, 5 over 8, and lastly, -3 over 8. So that is the inverse we need to use to this inverse to solve the following system of equation. The system of equation is x plus 2y plus 3z equals to 6, and 2x plus y plus z equals to 5. 3x plus y minus 2z, this is equal to 1. we need to use the inverse obtained in B1 above to solve the system of equation, which is this. Here we need to solve for x, y, and z. There are 3 unknown here. It's just the normal simultaneous equation, but in this case has 3 unknown. So what we need to do, first we write the given system of equation, system in matrix equation. So we write the given system of equation in matrix equation. So we just take the coefficients here. The coefficients are 1, 2, 3, 2, 1, 1, and here coefficient 3, 1, negative 2. This is the matrix times the variable x, y, z. This is equal to 6, 5, 1. This is now called the matrix equation. Now because we have the inverse, this is the matrix, the same matrix that we have used to find its inverse, which is this one. Because we have the inverse of a matrix, we just pre-multiply the inverse of matrix M, which is this one, into equation star. You can call it this equation star. Then we pre-multiply the matrix, the inverse matrix here obtained in this equation star. So you get pre-multiplying. So pre-multiply. Very important to remember this. Pre-multiply M inverse to equation star. Pre-multiply means the matrix M inverse comes first. So this will be just M inverse times the matrix, which is 1, 2, 3, 2, 1, 1, 3, 1, negative 2 times x, y, z equals to M inverse times the matrix, which is 6, 1, 6, 5, 1. So that is what we mean when we say pre-multiply the given matrix. Again, we use the factor that, using the fact that because this is just matrix M, when we take inverse of a matrix times matrix itself, what we expect to get is just an identity matrix. So here we have now identity matrix. 3 by 3 identity is just 1, 0, 0, 0, 1, 0, 0, 0, 1. Then multiply by x, y, z. This is z, sorry. Equals to M inverse, which is that one. I just take it. Negative 3 over 8, 7 over 8, negative 1 over 8, 7 over 8, negative 11 over 8, 5 over 8. This is 5. And negative 1 over 8, 5 over 8, negative 3 over 8. Then multiply by the matrix, which is 3 by 1 matrix, 6, 5, 1. And of course, if you multiply this, this is 1 times x plus y, 0 times y plus 0 times z. For sure, I will get x. And if you take the second row multiplying with this, we get y. The third column row gives z. This is equal to we just multiply in a normal way. Negative 3 over 8 times 6. So it will be negative 3 over 8 times 6 plus 7 over 8 times 5 plus negative 1 over 8 times 1. That is first row multiplied by the first column. Again, we come to the second row multiplied by the first column. It should be 7 over 8 times 6. And then minus 11 over 8 times 5, then plus 5 over 8 times 1. The last column will be negative 1 over 8 times 6, plus 5 over 8 times 5, minus 3 over 8 times 1. So that is what we have. Just now normal multiplication. We have negative 3 over 8 times 6. 3 times 6 is 18, so this will be negative 18 over 8 plus 7 times 5 is 35, so it will be 35 over 8 minus 1 over 8. The second column, 7 times 6 is 42 over 8 minus 55 over 8, and then plus 5 over 8. And the last column is negative 1 times 6 is negative 6 over 8, plus 5 times 5 is 25 over 8. And then lastly, 3 times 1 is now negative 3 over 8. Just add this fraction, subtract. Because the bases are the same, that the denominators are the same, we can just subtract. Negative 18 plus 35 is just the 35 minus 18, which is 17. 17 minus 1 is 16. So get 16 over 8, the first one. So adding and subtracting the first column, the first row gives us x, y, z equals to 16 over 8. The second one, it will be 42 minus 55. This is 13. 13 negative plus 8. 5 is 8 positive, so it is 8 over 8. This will be 8 over 8. And the last one is negative 6 plus 25 is 19. 19 minus 3 is 16. So we have 16 over 8. Now this simplifies to 16 over 8 is 2, 8 over 8 is 1, and 16 over 8 is 2. So therefore from here, we have now x equals to 2, y equals to 1, and z equals to 2. So we have used the matrix method to solve the simultaneous equation. That is the inverse of a matrix to solve the simultaneous equation. Thank you. Let's meet next time for other questions.